Welcome everyone. Today we're going to do some logarithms. All right, intro to logs. So first thing you got to know is logarithms and exponential functions are inverses of one another. And if you remember from when you've done inverse of functions before, they're graphically related somehow. Do you remember how they're related graphically? Like the inverse of one function compared to the other? Do you know? Do you know or you don't know? Oh, okay, that's fine. So we're gonna show you when I'll graph it. But for now, let's go just a quick review of exponential functions. So exponential function is y equals a times b to the power of x. B is not a transformation, it is your base number. So exponents have a base number. That makes sense, right? Like, so it's y equals 2 to the power of x. So there's an extra letter there. So in this example, when b is bigger than 1, it's an example of an exponential growth. So something that kind of looks like this, where it starts off slow and then starts growing very rapidly. That's an exponential growth. When b is less than 1 and greater than 0, it's decay. So I'll do a different color for that. And it kind of goes down rapidly and slows down like this. So that's exponential growth and decay. Y is your future amount. X is the number of times A has increased or decreased. Basically your growth period. So to calculate x, you use total time divided by the time it takes for one growth period or decay period. And this is all from grade 11. This is not anything new. Example 1, I want you to try it. Do your best. See if you can do this right now, okay? All right, so hopefully you were able to do this pretty straightforward. Your initial amount is 50. Your b value is 2 because it's doubling. The total time is 12 days, and then it's doubling every 3 days, so that's the amount that goes there. Your x value is 4, and you should get 800. Now that's some basic stuff. The next question is where it's really asking you. So let's get that next question here. So how long until the population reaches 25,600? Actually, I'll keep it here so you can see the amounts. So B. Do you remember how to do this from grade 11? All right, this one here, let me start from the beginning. So this is your y value. Y is 25,600, right? So that's 25,600 is equal to A, which is still 50, which is B is still 2, to the power of x, and we're solving for x. The first thing you gotta do is divide both sides by 50. So boom, boom, we do that. And what is 25,600 divided by 50? Do you know? 112. All right, and that's equal to 2 to the power of x. Now in grade 11, you probably learned two methods like guess and check method, trial and error. And then perhaps your teacher taught you about logs. Do you know how to do logs? All right, so if you're confused about logs, this is how you use them algebraically in an equation. You can type this symbol, log, on both sides, because remember it's an equation, so you have to use it on both sides. And there's a special property when it comes to logarithms. That is any number inside the logarithm. What do I mean by inside? I mean like that the log is applying to inside the brackets there. If any of those numbers has an exponent, you can take that exponent and write it out in front of the log. You're allowed to do that. So now the question becomes log 512 is equal to x log base 2. And now, oh, sorry, another thing I should mention is log of a number is just another number. This is just a calculation that you use in your calculator. So you can just punch in log 5112 in your calculator and you'll get a number. And you can punch in log 2 and you can get a number. So these are just numbers. They're just fancy ways to write numbers. So don't be, intimidated by them. Just treat them like numbers. So I'm going to divide both sides by log 2, which is just a number. And now x is equal to log 512 over log 2. And that's your answer. So go ahead and do that in your calculator, see what you get. All right, so yeah, so you should get 9, which you got 9, great, amazing, and that's the answer. X is equal to 9. But question was asking for what? how long until the population reaches. Your x value, is it your time value? And if you look at the equation for x right over here, it's related to your time, but it's not actually total time. See, total time is equal to x is equal to total time divided by the time it takes for one growth period. So what you need to do is, since x is 9, 9 is equal to time over how long does it take for this population to double? Every 3 days. So then 3 goes here. And what is the actual value for t? Yeah, 27. So 27 days is the answer. So just remember, there's a one small little extra step. When you solve for x, you've basically done all the hard part. The easy part, a lot of students forget that last easy part, which you have to multiply x by your growth factor time. All right, let's move on. Okay, so now we're just going to talk about the basic definition inverse of a function. The inverse of a function f is denoted as f minus 1. The function and inverse have the property that if f of a is equal to b, then the inverse function of b is equal to a. So basically, you're swapping your x and y values. So if your y value, in this case, f of 5 is 13, your y value is 13, your x value is 5. Because remember, your x value is always the value inside the bracket there, according to function notation, f of x. Your x value is the number inside the bracket. So here, x is 5, y is 13. Now, if I take the inverse function and I sub in a value of 13 for x, then I know the value of y would be 5 for my inverse function, because they share that property that they have, kind of like inverse values when it comes to their points. So more simply put, the inverse of a function has all the same points as the original function, except the x's and y's have been reversed. So that's it. That's the simple way to do it. The graph of f of minus 1x is the graph of f of x reflected in the line y equals x. This is true for all functions and their inverses. So this is how they're graphically related, inverse functions. You have a you have a line, y equals x, which is this line right here, a diagonal line. And whatever your initial function is, let's say in this case it's a quadratic, it will be reflected as if there's a mirror here, and then all those points are being reflected, and that's what your inverse function will look like. And you don't have to actually do the reflection because it's a little confusing when you have an angled mirror to like reflect. All you have to know is that any value, like for example this value here, what's the point here? The one that I drew in red. What's that point? Yeah, minus 2 and 4, exactly. Minus 2 and 4. If I reverse this, what do I get? Yeah. And now let's draw 4 and minus 2. 4 and minus 2. Here we go. So you don't have to do the mirror image. You can just reverse the x and y values, and that's it. It's very simple. Do you get it? So that's inverse of a function. So now we're gonna move on. This is not logs. This is quadratics. You should have done this already, so we're gonna skip this for now. Okay, so we are moving on to review of exponential laws. These are important because these laws are very similar to the log laws. So exponents and logs are very similar, and you'll find that soon. So product rule, pretty straightforward. If I have x to the power of a times x to the power of b, the base values are the same. You can add a and b. A and b don't have to be the same. They just have to be numbers. Same thing with quotient rule. If you're dividing two values where the base value is the same, then the top value is subtracted from the bottom value, a minus b. That's how you can combine them into a single term. Power of a power rule is when you have a bracket and exponents outside that bracket and inside that bracket. So you just multiply those two exponents. Negative exponent rule, important. A lot of students make this mistake. X to the power of negative a is the same thing as 1 over x to the power of positive a. This is how you can change a negative exponent into a positive exponent. Kind of just flip the fraction. Now, a lot of students, what they do is they make a mistake and then they see x to the negative a. They're like, oh, let me fix the fraction. It's going to be x over 1 over a. And that's completely wrong. Do not do this. You never, ever, ever, ever change the exponent. All right? The exponent doesn't ever go 1 over. It doesn't change. It just changes from positive to negative. And the easiest one is exponent of 0, and that's pretty straightforward.